Swim bladder disease isn't real. That's not true. That's a hyperbolic tagline to get people to keep watching this video because that's what the YouTuber subreddit told me to do. Okay, but it's like kind of true. This is a fucking rabbit hole that I went down like quite some time ago and have had a soapbox about ever since. So to understand the problem with the term swim bladder disease, we first have to understand what makes a swim bladder. The swim bladder is an organ present in fish that either fills with or releases air to control the fish's buoyancy. That's how they go up or down. But have you ever wondered how they do that? Here's how. There's two main types of fish. There's Physoclistous and Physoclistous. Physoclistous fish have the type of swim bladder that, as far as we can tell, evolved first. So Physoclistous fish will swim to the surface, gulp some air, and swallow it, but instead of that air going into their digestive system, into their stomach, it goes into their swim bladder. It stores that air to either maintain neutral buoyancy or to go up, but when they want to go down, they deflate their swim bladder through something called the pneumatic duct. The pneumatic duct is a duct that connects their swim bladder to their intestines or their stomach, depending on the fish. Air gets pushed out, goes into the stomach, and they fart it out. They be farting. Sometimes they burp if they're being polite. So that's how a Physoclistous swim bladder works. But Physoclistous fish are where it starts to get a little crazy. This is actually one of my favorite things to talk about. I love this shit. They fill their swim bladder with their blood air. They have an organ called the mirable, Latin, I don't know. It's basically a bunch of blood vessels that connects their bloodstream to their swim bladder. They also have a gas gland, which is actually located inside of the swim bladder, and these two organs work together. The gas gland releases lactic acid, which makes their red blood cells release oxygen and CO2, literally separates the oxygen and the CO2 from the red blood cells. And then the ret mirable kind of like pressurizes and concentrates everything, and it pushes that gas from the blood into the swim bladder, and that is how they fill their swim bladder. And then when they want to deflate their swim bladder, they absorb that gas back into their bloodstream. What's cool is that fish that live at really high pressure, so like deep ocean fish, actually have another part of this system. It's a sphincter that physically stops air so that at high pressures, the swim bladder doesn't just like back into the bloodstream. Most fish you'll have in your aquarium don't have that. That's mostly like a deep sea evolutionary trait, but I don't know, I think it's cool, so I included it in the video. Other things that I think are cool that I'm gonna include in this video, there's some cases of fish who use their swim bladders in really weird ways in addition to buoyancy. The Arapaima can breathe air with their swim bladder. There's also the Goliath grouper, which uses their swim bladder like a damn drum. They have a bunch of muscles that surround their swim bladder, and when they want to communicate with other fish or scare off predators, they compress the muscles really fast, and it's like, it makes like a boom underwater. And it can be heard for like hundreds of feet. Divers usually describe the boom as something that you feel in your chest rather than something that you hear. Kind of like if you're standing right next to the bass speaker at a concert, right? That's very cool. That's very cool. That's cool, man. There's also some fish that don't even have swim bladders, or they have one in the way that we have an appendix where it's like, you're not using this thing, why is this even still here? You know what I mean? There's some other cool ones, but I'll spare you for now. All that being said, swim bladder disease is what us fish keepers usually call positive buoyancy. So if a fish is stuck at the top and they can't get back down, maybe they're even upside down from it, we call that swim bladder disease. But here's my gripe with that. First of all, half of the time, it doesn't have to do with the swim bladder. It's just constipation and bloating. And you know that it's just constipation and bloating and not actually a problem with the swim bladder if frozen peas or raising the temperature works. Raising your tank's temperature speeds up your fish's metabolism and can literally get moving again, therefore clearing the constipation and allowing the fish to swim normally again. Feeding things that are high fiber, like frozen peas, is giving them fiber so that they can clear that constipation and swim normally again. So in a Physoclistous fish that does not have a swim bladder that connects to their digestive tract, if frozen peas or raising the temperature fixes it, it was purely just constipation that had nothing to do with the swim bladder. In a Physostomous fish, there's like a little bit of nuance, because if their digestive tract is backed up, that also means that their swim bladder, which uses the same hole, is also going to be stuck inflated, right? But that's not really the swim bladder's fault. It's just constipation. If temperature or fiber fixes it, it's not swim bladder disease. Well, what about when it is a problem with the swim bladder? Because of course that does happen, right? It's generally accepted that true swim bladder disease is caused by a bacterial infection, but when I started looking into that, there's kind of more to it. Like, it's not like that's not true, but there's more. I'm gonna use this paper that I found for some examples of actual swim bladder disease, and then we're gonna talk about them. It's called Swim Bladder Disorders of Koi Carp. It was written by a bunch of people in 2020, one of which was a veterinarian, which I love. I love to see vets treating fish. I love it. So the researchers took 9 koi fish, which are Physostomous, by the way. They tested the fish sometimes through a necropsy if the fish had to be euthanized, and other times through sticking a needle into the swim bladder, pulling it out, and testing it for bacteria and a bunch of other stuff. And this is what they found. Case number 1 had a big tumor that was compressing the swim bladder and the presence of an infectious bacteria called S. zeamanensis. Case number 2 had parasites and a bacteria called Arapaima present in its swim bladder. Case number 3 was inflamed and a bacterial test was not performed. Case number 4 had parasites and Arapaima. Case number 5 had weird fibrous tissue growing all over it and a bacterial test was not performed. Case number 6 was described as dislocated and had white blood cell jello inside of it, and surprisingly enough, no bacteria was found. That's the craziest one. Case 7, 8, and 9 all contained S. zeamanensis, an infectious bacteria, and no other super crazy findings. So what the f does this mean? How do we break this down? So 6 out of 7 of the fish that were tested for bacteria did have one of 2 types of bacteria present in their swim bladder. However, 4 fish, so 44% of the study, had anomalies that were likely safe to assume the primary issue and the bacterial infection was secondary. And in addition to that, 2 of the fish had parasites in addition to bacteria. So again, also likely the parasites were the first problem, right? So 6 out of 9 cases in this study had more going on than just bacteria, and only 3 of them, 1/3, had just bacteria. On top of that, let's look at what kind of bacteria this was. So 2 out of the 7 that were tested for bacteria had Arapaima in their swim bladder. Fun fact, Arapaima are actually common flora of fish. It's something that lives in their gut and aids in digestion, and it's not something that usually causes a problem. But of course, this was found in relatively large amounts in their swim bladder where it's not supposed to be, and both of them that had their gut bacteria, Arapaima, in their swim bladder also had a parasite. Maybe safe to assume that the parasite is somehow what caused that gut bacteria to travel up through the pneumatic duct into the swim bladder. This paper doesn't explicitly say that, but I feel like that's safe to take away from that. Now, 4 out of the 7 had S. zeamanensis, which are infectious bacteria that live on the surface of water. So it's assumed that S. zeamanensis is able to enter Physostomous fish when they are up at the surface, gulping that air to fill their swim bladder. They also ingest some of the bacteria, it goes in their swim bladder, and it starts to colonize it. So that's the reason, that's the answer to why people say to maintain high water quality to prevent swim bladder disease. But it's always irked me when people say that, because what do you mean by high water quality? There's like 1,000 different water parameters, right? Which ones are we talking about? For swim bladder disease specifically, if we're going off of the idea that it's caused by infectious bacteria, when we say high water quality, what we should be saying is, hey, make sure your water isn't stagnating and isn't getting really, really filthy and creating a productive environment for infectious bacteria to grow on the surface of. In other words, do your water changes, right? Okay, so just to recap again, because I'm really into numbers, 2 out of 7 had a population of their gut flora found in their swim bladder, probably due to a parasite. 1 out of 7 had an actually infectious bacteria found in the swim bladder in addition to a massive tumor. Another 1 out of the 7 did not have a bacterial infection at all. And 3 out of 7, half, had infectious bacteria alone. Half. A little less than half. But it's just caused by bacteria? Really? You know what I mean? You know what I mean? In total, of the entire 9 fish, 6 out of 9 of the cases had something else going on in addition to the bacteria being found. Only 3 out of the 9 had only infectious bacteria. 1/3. To be fair, 2 of them weren't tested for bacteria, so we don't know with those. But in the total of the study, only 1/3 of them had infectious bacteria alone. So we can say that bacteria was present most of the time, but we can also say that most of the time there was another issue in conjunction with the bacteria that was potentially the primary cause. So it's not that it's not bacterial, it's just that there's a little bit more to it, right? And to be fair, this was a small study. This was a study of 9 fish, and we would have to do 900 to have like really good data on this. But I do think that that finding is pretty significant, right? Like that raises some eyebrows. Also, this study was only about Physoclistous fish. So what about in Physoclistous fish? Remember the ones that don't have a swim bladder that attaches to their digestive tract and they don't gulp air at the surface? How does it happen with those guys? How would an infectious bacteria enter their swim bladder? Would they have to have a blood infection first? Maybe it is still able to enter just through the mouth. We don't know. Like, we don't know. At least not that I could find. If someone can find a study on that, please do, because I looked, I couldn't find one. So in the beginning of this video, I said swim bladder disease isn't real. I was lying. It is real, like a buoyancy issue caused by something going on internally is real. But what causes it is not the same in every case. And the study itself also outlined some other causes that weren't found in this study, but they were just saying like, this could also potentially be a reason. Those include swim bladder collapse, overinflation, displacement, deformity, herniation, stress conditions, and neoplasms. So what are the practical implications of this for the fish keeping world? Like how does this help us as fish keepers keep our fish alive and healthy and happy? I don't know. I don't know how this helps people now. What I do think that this does is kind of really exemplifies the need for more veterinary interventions with fish. We need more vets that will see fish. We need more vets that will perform diagnostics and prescribe medications, you know, better than we can over the counter. We need more vets that will perform operations on fish. We need more vets that will treat fish and fish keepers seriously. And yeah, I know that people are always going to say like, oh, well, who would take a fish to the vet? Me? A lot of people that I know? Like, people spend thousands of dollars and hundreds of hours on their tanks and on their fish. A lot of fish are incredibly smart. People are able to bond with them. There are absolutely people who would take their fish to the vet if they were able to access it. Fish deserve a happy, healthy, pain-free life, just like every other animal that we keep in our homes. And it's possible. It's more than possible. There are so many veterinary things that can be done for fish. And to exemplify that, I am going to leave you with a quote from this paper's conclusion. Cytological and microbiological investigations can be easily and quickly performed to drive the medical intervention and raise the chances of fish survival. That's what we need to do. Okay, bye.